How do quadratic equations design parabolic arches and bridges in algebra? Have you ever looked at a beautiful bridge and wondered how it can hold so much weight while looking so elegant? The answer lies in the fascinating world of quadratic equations. Today, we will uncover how these equations help design parabolic arches and bridges in algebra. Quadratic equations describe parabolas, which are U-shaped curves created by a second-degree polynomial function. Typically, a quadratic equation is written as y equals x squared plus bx plus c. When you graph this equation, you get a parabolic shape. This shape is essential in engineering, especially when designing structures like arches and bridges. Let's start with parabolic arches. These arches are shaped just like the graph of a quadratic function. When an arch supports a load, like the weight of a bridge or vehicles, the internal forces follow a parabolic curve. This means that the shape of the arch is perfectly matched to the curve of a quadratic equation, making it efficient in spreading out the forces evenly. In bridge design, engineers utilize quadratic equations to model the arch's shape. They begin by determining the vertex, which is the highest or lowest point of the parabola. By defining other points along the arch, they create an equation that describes its curve. This equation helps engineers figure out important dimensions, such as the height of the arch at different points and the width it spans. For example, if they know the maximum height and width of the arch, they can calculate a quadratic function that fits those specifications, ensuring the design meets all requirements. Parabolic arches are particularly effective because they create strong thrust at their bases. This means they push outward at the bottom supports, allowing them to span wide areas. This characteristic is especially useful for bridges that need to cross valleys or rivers, where long and sturdy spans are necessary. There are different types of parabolic arches used in engineering, including three-hinged, two-hinged, and hingeless arches. The choice of which type to use depends on factors like how long the span needs to be and the complexity of the structure. Three-hinged arches are simpler to analyze mathematically because they are statically determinate, meaning the forces can be calculated directly. On the other hand, two-hinged and hingeless arches are more complex but allow for longer spans and better material efficiency. In essence, quadratic equations form the mathematical basis for designing parabolic arches and bridges. They define the precise curved shape needed to handle loads effectively. Understanding these equations helps learners see how algebra connects directly to real-world structures, making the concepts more relatable and easier to grasp. So, the next time you admire a bridge, remember the quadratic equations that make such impressive designs possible.